All right, I'll get started. Okay, so hi everyone. So thank you for coming to my talk. So my name is Wijnand. I work at Lightbend. I've been a maintainer of SPT for many years, and but recently I've moved more into sort of like the application space, and now I work on plain Lagom at Lightbend. I maintain a few SPT plugins, and I also accidentally started maintaining Mima. So, and I propose trailing commas in Scala. So if you love it, if you did hate it, it's both ways. It's my fault. I love it. You love it? I love it too. So as I say, yeah, thank you. Justin is giving a talk on BSP, which I think is a very interesting project. So I actually do recommend you watch that talk when the recording comes out. But thank you for coming today to see my talk. So just to understand the audience, how many of you are or have experience as a Scala developer? Just to get, all right, I feel like it's everyone. Some people, you know, it's good. And how many within that are library authors or library maintainers, whether it's open source or internal libraries? You know, that's about half, maybe a little bit less. Good. Just as an aside, completely unrelated, how many of you library authors, by show of hands, use Mima? Just to understand. Use Mima. So Mima is the migration manager. Well, it's a tool for checking binary compatibility in a library, and it's very important for binary compatibility. So less than half. All right, use it and help maintain binary compatibility. All right, that was the aside. Last question: how many of you know the shortcomings of PartialFunction? Like why we sort of it needs to be fixed? Okay, so that's about a quarter. Okay, all right. So this is the agenda. I'll give some a sort of build-up definitions. Oh, thank you very much. Of PartialFunction and function one. Thank you. In Scala, how it's used, how it's implemented in terms of like how the compiler implements literal function syntax, and what the problem that it has, and my proposal, and then I'll summarize so that we can have an overview for any questions or comments. And you know, feel free. You know, we're in a smaller room, so you know, feel free to jump in if you have any questions or comments. Okay, so definitions. So what's function one? So this is function one that we have in the standard library, and we use it throughout the standard library. We use it throughout the ecosystem, and it's very handy to have. Well, it didn't exist in the Java standard library, so we put it in the Scala standard library, and it's part of the specification of the language, yeah. So we use it throughout, and we collaborate based on this type. But it also has a type alias, which we normally use. So the class is function one, but we just use the infix arrow, which is you know, like the typical syntax of the type is the one on the right, the comment. So it's type parameterized with A and B, but we use an infix. And in reality, you can use any type. So I could put function one where the arrow is on the left, and be A function one B, but we don't do that. But anyway, just a general rule about Scala, you can actually do that, but you only want to really do it for operators like the arrow. Additionally, it is special. So this type alias is it's in the spec, it's in the language, it's in the compiler. It's not in like Prelude or something. It's not in the standard library. It's special, and it's special because it's right associative. So any other type alias that you would define and use infix would be left associative. The things that are right associative are the ones with a colon. So when you have cons, the colon on the right makes it right associative. So That's why in shapeless and HList and a few other things like that, where they want to construct a thing, but they want to maintain right associativity, they always do it with a colon. And then for symmetry, they put on both sides, and maybe it's star or plus or a combination of things. But function 1's arrow is special. It defies this rule, and it's right associative like this. This is relevant for what's coming up. So partial function is this. This is not a complete definition, but it is the basics of what partial function is. It extends function 1. I use the more common syntax, but it gets a little bit hidden. So it has an apply as well, A to B. And it adds is defined at. And the definition in the documentation, which I've not included here, talks about how partial function changes and makes it so not all values in the domain A the function is defined for, and then this added method defines that. And that's the partial part. So because my talk is about partial function, and sometimes I do some work with partial function, I typeface it, right? Because it's just really, it's the reason why we don't use function 1 is because it's verbose and you don't get to use it, well, you don't really want to use it infix. So I want an infix thing that I can do the rest of my talk in. This is the type alias that I want to use. There's the isDefined part at the beginning, which I use to see whether my input is defined for the function is defined for the value. And then there's the apply part. So that's why it's question mark equals. In the past, I've put the question mark in the middle, but it's better at the beginning because it makes sense. It shows really that really want to check if it's defined, and then you want to run it. So just an alternative that I've used and other people have used. But from what I said earlier, I want to make it right associative. Now, I probably won't be defining. Actually, in my talk, in my content here, I don't have any partial function to partial function, but you don't want to get surprised. You don't want it to look like it's partial function A to a B, which is partial function to C. That's what you want, and you don't want it to do the other thing where it's less associative, where it's a function that expects a function. So I put a colon at the end, which looks terrible. But it's a hack, it's a workaround. It's to allow me to make sure that I don't accidentally build something which doesn't associate the way I want it to. Just an aside. So function 1. So we'll jump back to function 1. So function 1 has these added methods. Some of them were present in the keynote yesterday. To allow, these are combinators, allow to combine functions together. And we have it in one way and the other. And some of them work better than others. Some people prefer. In a way, it depends on which way you're thinking about the problem, whether you're thinking about it so from the result, how do I get the result from the input? So you might work backwards from compose. Other times you go from the input to output, like you reason about it that way. So some people go from and use and then. For type inference, sometimes you want to use one over the other. So, but both are available. By the way, I took some artistic liberties and like renamed parameters and obviously formatting, and there's no apply here because I showed it earlier. So this is not like complete code. And then partial function. Partial function has a lot more methods, a lot more utility things in it. So we'll go through and explain it. So as I said, so it extends function 1. I kept that at the top. Is defined, I explained earlier. So and then exists on function 1 and exists on partial function. Compose, and it adds or else. So because it's partial, you might want to have a sort of fallback partial function. So if you see like G is a partial function from A1 to B1, which has a relationship with A and B, and that's part of the result, that defines the result. And so added, so because it's partial, you might want to operate on it as a function 1 for for whatever reason, as in like maybe you prefer it or maybe your API requires it. So there's a lift. And I just added, there's also an unlift, which is an extension method on that, exactly, on A to option of B, to go back to a partial function. There is unapply, which is an alias of lift, which allows partial functions to be used as matches. So you can define something as a partial function and then do case and extract the thing that that it applies if it's defined for the thing. Element-wise is a recent addition. Has it shipped yet? I'm not sure. It's either in 2.13.1 or 2.13.0, but it's the other. It's the one where you. It's like where in Seek you can match and do the case and you extract like there's 3 elements in it, or there's 3 elements and you don't care about the rest and you just want to take the 3 elements. So that's another part of pattern matching in Scala. And so someone saw the apply and saw that you couldn't do the other thing. So I can't actually remember exactly. It must have not shipped because I haven't played with it yet. But it's about being able to do that thing. I think so. I guess you have a sequence and you want to say, let's say, take only the uppercase strings. So you have a partial function defined only for uppercase, and then take the first 3 for whatever reason. Element-wise, apply or else. Apply or else, in some ways, because there was a redesign of partial function. But apply or else, in a way, is kind of the definition of or maybe the alternative definition of partial function. You apply something if it's defined, and you have a fallback, which makes it safe. So apply or else is always the safe function that you can use. It's also cheaper, and so all these combinators and then they're quite complicated. As in, like there would be a simpler implementation for them, but they do things like override definitions just to make all those operations cheaper, such as or else. So when you want to do, let's say, you want to combine things together with or else, it will go and redefine apply or else so that it's just a cheaper operation, sometimes for memory or for CPU or whatever. Run with is, I really don't, I haven't seen it used much, but it's good to know that it's there. So it allows you to safely call, so do an operation action if it's defined. There's a couple more on the object of partial function, and these are utilities that are basically not as well known. Some of them are not hugely useful, I found in my experience, but it's good to sort of like overview them. From function, I think is also a 2.13 edition. There wasn't an apply which sort of didn't do the right thing. It gave the impression that so from function takes a function, but if you use case syntax for that thing, the partial function it gives back to you is not partial in that case syntax, because the target, this is like implementation detail of Scala, the target type of the parameter is a function 1, and that means that the compiler won't generate a partial function that records where it's defined and where it's not defined based on the case. So we killed apply and called it from function. So it's clear that it's from a function that you're constructing a partial function, which is always defined. So if f is partial, it's going to blow up. It's not a partial function, and it is a partial function, but it's not. It doesn't preserve that information. Condition and condition option, kind of sometimes useful. I use them sometimes in SPT, but mostly. Fallback, this is the whole machinery that apply or else uses that makes it cheap, and it's using the cheat codes like as is and so and EEC, which is identity equality, and that's what makes it cheap. So. Those are the definitions. So the question now is, when do you want to use a partial function? So there are 2 cases that I know and I've seen in which you want to use a partial function. The first one is when you want to operate only on part of the input, so that's the partial part, but you don't want to pay the runtime cost of boxing with an option. So the lifting will give you an equivalent function, but in terms of when it runs, it has the additional cost of boxing the option. So if you want to be able to avoid that cost, PartialFunction exists to allow you to define an API or define behavior that you want in which you avoid that cost. So yeah, or else, and so forth. So for example, collect exists on the collections in Scala, and it takes a PartialFunction. So here I want to do something about all the strings that start with foo underscore, and so now it's going to construct a collection, but I haven't built a whole bunch of sums for all the values I want to keep, or use none for all the other values, etc. So it's cheaper. There's also Aka's actor receive, where you might only have a part of the input, and you want receive to just handle the fact that it's not going to be defined of anything. It's got to do something else for methods that aren't defined, dead letters or something else. The other one that I know is because you want to be able to, you want to be able to define a function at the end of the world, but we have these components, and you want to define them and combine them in different ways. So you want to use the or else combinator, which exists on PartialFunction. So it's convenient for you. Maybe it's part of configuration whether something is used or not. So here, you recover when there's no user in some ways. If it's that, it's a problem about no tokens. If not, you fall back to some PartialFunction, which is actually defined for all problems, where you just sort of record it, right? So these are the two use cases that I know that are useful for PartialFunction. So we jump into implementation. So how does this, so by implementation here, obviously I've shown you the classes, the methods. I highlighted some of the bodies and some of them I showed. But when you define case, match, and cases, what does the compiler do? How does it construct that PartialFunction? So what it actually does is something like this. So there's an abstract PartialFunction. I think it's in runtime, like scala.runtime, but I can't remember. But it defines apply in terms of apply or else, and actually defines apply or else. And the reason it does this is in order for, maybe I'll jump back just to, I'll come back here, but because of the definition of apply or else here, where it checks if something is defined and then runs apply, otherwise it does the default. You don't want to run the matches just to check if it's defined, and then run the matches again to actually do the apply. So that's why the PartialFunctions that we get when the compiler generates a PartialFunction actually implements apply or else. So it does the cases once when you use apply or else, which is, as I said earlier, is sort of optimized and kind of the point of interactions. And when you want to combine PartialFunctions, you want to use apply or else because it optimizes here, as opposed to the combination of is defined and apply. So yeah, so as I said, yeah, so it does. It takes the original selector and does the bodies of the cases in the apply or else, or it does the default if for any fallback, for any case that's not covered. And then it does so in the is defined at, it takes those bodies and throws away and puts true. So that's cases true. I haven't shown implementation, but basically it's taking and keeping all the left-hand side cases, and the bodies are just true. So which allows, obviously, the fallback to be false. So the problem. So what problem does PartialFunction have? So here it is, function one and PartialFunction. I've shown apply again. So the problem is that the apply of partial function and the existence of partial function allows for values to not be handled by the function. So in Scala, on the JVM, definitely the Scala compiler, we don't have a totality checker. We don't know for a fact, given a piece of code that defines a function, that the function handles everything. There's nothing that checks that for us. So absolutely, any function can fail. It can, throwing exceptions is, is not difficult. There's easy syntax. The question mark in Scala is a handy tool for development, which makes it super easy to throw exceptions. So there's no guarantee that functions are total. But we do have organically, it's actually not in the documentation, there's no mention of this at all in function 1's documentation, but there is an organic, like we've grown organically to build like the standard library and the rest of the ecosystem Scala, whereby it's expected that function 1 is defined for every value of a, or most values. Like there might be like some exceptions, like we expect it only to be given, let's say, positive integers, and that's understood by the context perhaps, maybe in the name of the function or something. Maybe it's not all of them, but that's definitely an expectation where you won't be surprised if it's partial. Partial function comes in and makes it suddenly so much more acceptable for it not to be defined for values in its domain. By is defined at, and as I said earlier, by the ergonomics of defining case, like the foo underscore thing that I showed, where it's like, and if not, then like it's not defined, right? So the problem is that the apply of partial function and the apply of function 1 don't have the same expectations. The expectations of function 1 is that it's safe to call, and the expectations of partial function is, check, because it might not be safe to call. So, in my opinion, partial functions change the expectations of apply. So, I need to double check this, but my impression is that partial function breaks LSP, so Liskov substitution principle. When you have a value that's of type function 1, having a value of partial function, and these two things having functions with different intended semantics, I think breaks the principle. So the question is, why do we have this, and why we've had this for so long? Now, it took me a while. Like this has been debated a bunch of times throughout the years, and the debate that has been made against it is that we are adding something. We're adding a method is defined at, right? So partial function is everything function 1 was plus a method, right? So we can add a method and therefore it's safe. And so some people have reasoned about it, saying, as I said earlier, no function is safe. But partial function, you can ask questions to it. Before it blows up, you can say like, would you take this function? Would you take this parameter? Would you take this parameter? So, one argument I think everyone agrees on is that it probably, for that argument of this sort of like you can ask a question, like query it, it should have a different name, perhaps a queryable function, where you can query something, and it's because partial function is a thing in mathematics, and so many people, the argument that people have made is that it's backwards. All total functions, all functions are partial functions, but defined for all parts of the domain. So I think it's been this sort of misunderstanding between sort of adding a method and but there hasn't been this reasoning about apply and how partial function just basically redefines apply, which it doesn't get to do. It's already been defined by its parent. So just as an example, what did I do? Oh, I went up. So here's an example. Map. just, I wrote a map, I gave it some syntax. This is not a compilation error. This is a runtime error. And yeah, so I made a mistake, but the compiler never checked this. Like, I used some features in the language, and it was totally fine for map for this to happen. So here's an example, of just using two features. I used a method on the standard library and the case syntax, and the compiler didn't help me here. So yeah, just as another way, the whole point is that you get a function one. Is it safe to call apply on it? Can I? What should I? Am I meant to? Given this thing that partial function does, should I check every time whether it's a partial function, or should I just try? Do we not get to call any function ones because it could be a partial function? It's flawed. It's a flawed design. There's a small additional problem, which is the opposite effect. So recover here takes a partial function, and I have a function. I have a function that I want to use as a fallback. Just use one as a fallback value. I can't use a very straightforward fallback because it takes a partial function, and function one being the supertype, it doesn't type check. So. But much smaller than the other problem. I've actually fixed this one. I put a pull request a few months ago, and it's coming in 2.13.1. So much smaller problem, but it's useful if you do. If you use a lot of partial functions, either standard library or in akka, they use a whole bunch. So this will be solved. So proposal. So I actually have 3 proposals. This is the good part. So the first one is the optimal solution. There are 2 changes. The first one is we make function one extend partial function like God intended. And the second one is we split the 2 applies. They are different things. They are different functions. They should have different names. So here we go. So instead of having partial function have an apply, we give partial function an unsafe apply, which makes it very clear that it could potentially throw a match error. And you redefine apply or else in terms of that. And what you do is when you extend, when function one extends partial function, it just defaults these things. So it introduces and immediately defines apply to call unsafe apply. We can do it the other way. And basically, there's just aliasing it. So we're aliasing unsafe apply and apply together. We could do it this way around, or we could do it the other way around, where unapply is defined as apply, and then we go and implement apply. So this allows us to disambiguate at the call site when you're calling unsafe apply or apply. I actually did it this way around because I think unsafe apply shouldn't go via apply, but it probably doesn't even matter for the JIT. So this is my, what I believe is the optimal solution. Specifically, function one is still a SAM type, which my understanding is that's very important for performance. There's this whole machinery that happens in Java 8 plus, where it's single abstract method types. So when you have some kind of interface with just one method, it does a whole lambda thing, and it's sort of optimized for that. So it's important that function one continues to be a single abstract type, so that all that machinery still kicks in and keeps things fast. So the benefit of this is that everything surrounding it gets just a lot easier to reason about. We don't make the mistake of consuming a partial function disguised as a function one and thinking it's safe and it's not. Also, the implementation of everything. Oh, I completely skipped to mention this. Yeah, we'll jump back all the way. Here. Look at and then, compose, and or else, right? So and then exists on partial function. And here it's so it's overriding it to refine the return type to be partial. Then it's actually also overloading it to handle a parameter type which is a partial function and also returns a partial function. Compose is an overload in the subtype, which takes a partial function, and or else doesn't exist on function 1. And it does this thing where it like narrows the input type or allows the input type to go narrow and allows the result type to widen. And like, do we have all the combinations right? Like, do we have others that we should be adding? I'm not sure. I fixed one part of this in time for 2.13.0, so I'm not 100% sure that we've got all the combinations right. And part of that complication is because we need to sort of like retroactively double check, like, or if it's partial, then we've got to deal with the fact that you're partial. So going back to my optimal solutions, proposal 1, the implementations of all that stuff get simpler. It's easier to reason about because it's natural and logical, and you can't do the wrong thing. Yeah, so you benefit from all that. You don't have to reconstruct and we don't have to get bug reports about bugs in the standard library that we can only fix later. So the problem with this proposal is that it's the migration to get here. So if we could throw everything away and just ship this, it would be fine. But we have a bunch of existing code bases that we'd have to migrate. And I care deeply about helping people migrate. And I think this proposal, while optimal, would be too costly.
Will it make it for 3.0 though?
Well, I think this one's not possible. I think but I'll go through the other ones. But my plan in my head would be something like we introduce another variant of partial function, which we put as the supertype of function. We deprecate the partial function we have now, and eventually get rid of it. And with it, because we have to have two at the same name, the new one can't be called partial function. We probably don't want to have it like in a different package or alias or something. So we just throw away partial function, sadly. Like we lost our chance to name it properly. And it's probably not worth it for whatever we do call it to then have another migration just to fix the name. You know, that would be too silly. So something like this, it might be called. So just be PF, right? Nice and short, right? I can use it a bunch of times in my slide. And yeah, so function 1 would extend PF, and then the old partial function would extend function 1. Additionally, what we could do, and this is not just this proposal, all my proposals for partial function, we could also add the alias with the question mark equals greater than in the compiler with the same exemption that function 1 gets, so it's right associative. So maybe it's not a huge problem. It's called PF because at the end of the day, it's like function 1. It's not what people actually use. I mean, I guess they'll see it in a stack trace, but whatever. So that's one idea. But the problem is that so first of all, we're adding two things, so people got to wrap their head around and tell their colleagues and ops. So why do we have partial function PF? What are these weird things? The other thing is we have this literal syntax, which is case syntax, which today, if the expected type is a partial function, it gives you a Scala.partial function, which is the bottom one. So do we just switch? At some point, 2.14, 3.0, 3.1, at some point, do we just do the other one? Now we're doing the super type? Or do we do it behind a language flag? Or I don't know. That kind of feels really subtle and especially while both things exist at the same time, I think it'd be confusing. People would be staring at especially when they're cross-building, like library authors, their 3.0 code and their 2.14 code would one would give PF, the other would give partial function. So we're going to alias them, so we can have a common name. This might get really hard, right? So I don't know. I'm not convinced about this one, but it would. But without the migration, I think it would be the optimal solution. So the other idea is we can just drop the inheritance, right? So what does that look like? So we still do the unsafe apply, which is, again, addressing the main concern where these are two different functions. But function 1 no longer extends partial function. They're just different types. we would keep apply on partial function and have it deprecated so people would migrate away from it. When we drop the supertype and when we do the deprecation, we'd have to figure some of these details out. But the idea would be while every total function is also a partial function, so that is not why it's not the optimal solution, but this would be easier to do, I think, because again, we don't have to have two types at the same time. Just at some point we would drop it, and as I said, the various different changes we'd have to time properly. And we would probably add a way to go to do the thing that we can't do by inheritance. So going from a total function to a partial function, we might have a utility method like this, which you could use like this. If you had a value which is a fallback function, but you give it to something that handles a partial function, you might have to call a method. I wouldn't do it implicitly. I would just do it explicitly. We might not even add a method because you can just do it with eta expansion. As of my change in 2.13.1. So maybe that, I don't know which one's better, maybe both. Maybe we still add as partial function because it's more clear. Additionally, because there's no overlap, if in whatever scenario you construct two things and sometimes you consume it as a function one and sometimes you consume it as a partial function, I don't know what system this is, but if you had such a situation, you can just mix in both traits, right? The point being here is that you're not constructing, say you have 100 of them, you're not constructing another 100 copies which are wrappers of the original. You can just mix in both traits if you have access, obviously, to where they're constructed. So that's what I think is probably the most likely solution. But there is one more solution, which I've not explored as much, but might be even more appealing. So what if we had an unbox option in the standard library? Now, I actually want this for like a lot, like for many, like apart from this, I want this. I think it's something that, I wish we because there was the whole thing about dealing with nullable or null in Scala 3, but that kind of dropped away. So I really would like to be able to have unbox option, not have to pay this runtime cost. The reason the proposal is because one of the primary reasons was the runtime cost. So can we not just deal with it some way? Can we not just avoid the boxing that we have? We have opaque type aliases in Scala 3. Can we use that? Is that good enough? That's super handy in order to have basically a new type, but without boxing. So could we redefine partial function with it? So with the unbox, so opt and function one. So say, so at the top, the type alias, which is the partial function, is A to opt to B. And then we just add extension methods to that, the ones that we have on partial function. Like could we do something like this? Maybe, I'm not sure. I want to. The nice thing here, of course, is that like the whole lift part means that some people prefer to reason about it this way. There would be no runtime cost. We can extend it to add or else, so we can have all that behavior. And generally speaking, if you can compose things together rather than special case things, maybe not all times, but often it's preferable. So that's proposal number 3. So just in summary, so the first one is the optimal solution, the one that is in mathematics. You have function 1 extend PF, you have partial function, you eventually get rid of it. You have distinct types, distinct function 1, partial function, and you carefully decide in what version things get changed. And the last one is you introduce unbox option and you construct a partial function from that and the utilities that people need. So what do you prefer? What are your thoughts? Please?
As we, in many cases, we're putting compatibility with previous versions. Well, I'm feeling pretty uncomfortable with the idea that we leave some kind of ply or unsafe ply syntactic partial function that stands a function, but not A to B, but A to option B. And even if we have overhead for generating an option, we might generate also implementation for apply else and use it when we need to deal without an option. Provide some another function that could make this function total.
Sorry, say the last part again?
So that's close to third proposal, but I think we could do it with the current option implementation, and that would be just fine, as we get rid of exceptions and match errors.
Okay, so we would. So the exposed API would of let's say of apply would be option, but it would still have the necessary information to have a cheap apply or else.
In compiler, we may generate private implementations for if defined and for actually implementation for a function. That would be private. That would be available as public methods, and then we will wrap it into the standard apply method of a function, A to option B, and then if we just generate an implementation that if we have if this function is defined on A, so we return some of the application. Otherwise, no. And then we can generate apply or else that would just convert, choose another implementation that would make this function of A to B total.
Yeah.
I see. Like
Please.
Go for the ideal option. The argument that that it's painful and there's a huge installed base.
Yeah. How do I? Do you want to come explain your ideas? Sorry, Paul.
Yeah, no worries. Yeah. The curse of being tall. So go for the ideal option. The problem is that the argument that you have a huge installed base and it's going to be excruciating for all of them is a truism. It's not overcomable, assuming that you have a successful language at all, in which case, nice problem to have. But you're already in the process of heading towards Scala 3. You already have to develop tooling to help library authors and framework authors and so forth make that transition. So now you have one more line item in the things to help them make the transition too. And because part of the theme is already to make the language and standard libraries more rational with the new implicit proposals and so on and so forth, you're already headed in a for lack of a better term, greater cleanliness direction. So this is another cleansing that you can introduce at that point. It's never going to get easier. I really, really hate the argument, oh, we have an installed base that already depends on this wart. It's never going to be easier. It's never going to get easier. Just
sure. Okay. So I agree with a lot of you said, what you said, but so in a way, I think we've at least the way that we try to plan it is to do the necessary changes in the standard library in 2.13, and I guess the intent is to do some modifications at some degree of breakage in 2.14, and then if I understand correctly, it'll be one-to-one. The standard library 2.14 will be the standard library 3.0. Now, the partial function, as I said, is part of the spec. So in a way, it's more like core Scala. It's kind of like the language of Scala. So you could say it's part of a language change as opposed to like a standard library change. But I don't know. I kind of I'm happy to explore with the Scala governance, the Scala team, the Dotty team, Martin. But I don't know. I just feel like maybe I missed my time window to do this change. Like 2.13 was the time to get people through 2.13, 2.14, and then we can do the 2.14. It's sort of too late maybe. So my intent here is to collect feedback and from whom I can and propose a SIP for this. And then that conversation will decide if this is a 2.14 SIP or 3.0 SIP or 3.1 SIP. Anyways, that's my intent. But thank you for both your comments actually. Please, I'll try and repeat the comment.
I was just going to say the unboxed op would be pretty useful regardless of the party. And is it necessarily a coupled affair?
Yeah, unbox option would be awesome anyways, I agree, 100%. Anyone else want to work on proposing that? Last question.
And the question, so maybe it would make sense to go the path of proposal 2, then proposal 1. So once we eliminate the inheritance, which we could maybe do in Scala 2. I don't know, we could maybe then make things as God wanted it in Scala 3. That's just a thought.
Break the inheritance first and then reverse it. Maybe, good idea.
And a question regarding the proposal 3, wouldn't it make sense to actually express the option type as a union type?
No.
Yeah, so we would have a singleton none thing, and we would union it with whatever A we want the option A for.
So maybe one thing, there's one property of sort of unboxed option, which is the ability to understand how many layers are available. Many times people want, right? So probably, it's a useful property I think to hold. All right, well, thank you very much.